Next one is view serializability. Need of view serializability. There may be some schedules that are not conflict serializable but still gives a consistent result because the concept of conflict serializability becomes unlimited when the precedence graph of a schedule contains a loop or cycle. In such a case, we cannot predict whether a schedule would be consistent or inconsistent. As per the concept of conflict serializability, we can say that a schedule is conflict serializable if it is corresponding precedence graph does not have any loop or cycle. So let's see how to determine whether the two cycles are view equivalent. S1 and S2 are said to view equivalent if they meet the following conditions. First one is initial read, second one is final write, and the third one is update read. Initial read. Initial read of each data item in transaction must match both schedules. Final write. If in both schedules the final write operations on each data item must match. Update read. If transaction T1 in schedule S1, if transaction T1 in schedule S1 is reading data item updated by T2, then in schedule S2, T1 should read the value after T2's write operation on the same data item. View serializable. When a schedule is view equivalent to its serial schedule, it is said to be view serializable or view serializability in DBMS. Check whether the given schedule S is view serializable or not. If yes, then the given then give the serial schedule. There are three transactions, that is T1, T2 and T3. In T1 transaction we are reading A, and T2 transaction we are writing A. In T3 transaction first we are reading A. After that T3 control is transferred to T1, writing A. After that T1 control is transferred to T3, we are writing A. We know if a schedule is conflict serializable, then it is surely view serializable. So let us check whether the given schedule is conflict serializable or not. List all the conflicting operations and determine the dependency between the transactions. R1 of A, W2 of A, that means T1 to T2, then R1 of A, W3 of A, T1 to T3, W2 of A, R3 of A, T2 to T3, W2 of A, W1 of A, T2 to T1, W2 of A, W3 of A, that means T2 to T3, control is transferred from T2 to T3, R3 of A, W1 of A, dependency, T3 to control is transferred to T1, again W1 of A, W3 of A, T1 control is transferred to T3. So for that you have to draw the precedence graph. In this graph we are mentioning the dependency between T1, T2 and T3. Clearly there exists a cycle in the precedence graph. Therefore, the given schedule S is not conflict serializable because we already seen if there is no loop in the cycle, that is call it as conflict serializable. Here there is a loop between T1, T2 and T3. So this is not conflict serializable. Now, since the given schedule S is not conflict serializable, so it may or may not be view serializable. To check whether S is view equivalent, view serializable or not, let us use another method. Let us check for blind writes. A blind write is when a transaction write a value without first reading it. A blind write must be present in any view serializable schedule that is not conflict serializable. Checking for blind writes. There exists a blind write W2 of A, that means in second transaction in the given schedule S. Therefore, the given schedule S may or may not be view serializable. Now, to check whether S is view serializable or not, let us use another method. Let us derive the dependencies and then draw a dependency graph. T1 first reads A and T2 firstly updates A. So T1 must execute before T2. Thus we get the dependency T1 to T2. Finally, updation on A is made by the transaction T3. So T3 must execute after all other transactions. Thus, we get the dependency T1, T2 to T3. From write read sequence, we get the dependency T2 to T3. Clearly, using this precedence graph, we can find out there exists no there is no cycle in the precedence graph. Therefore, the given schedule S is view serializable. The serialization order is T1 to T2, T2 to T3. Thank you. Remaining things we will see in next class. Thank you.